Hi, welcome to this video on the surface area of triangular prisms. So the first thing you want to have is this worksheet in front of you, surface area of triangular prisms, and we're going to try a couple problems together. One thing you need to know is that surface area just means the area of each face added together. So as I look at this first problem here, number 1, I can see that there are one face back here, there is a slanty face back there, there's another slanty face that's on this side, here's the third one, and then if I look at the bottom of this tent type shape, there's a face down here, and then there's a front face right here. So what I'm going to do is I'm going to take that apart piece by piece and draw a rectangle or triangle to represent each of those faces. Okay, so I'm going to start with this first triangle here in the back, and I'm going to trace it, and then I'm going to write the dimensions on the triangle I drew over here. I kind of like cut that off the piece, and then I'm going to write. So this slanty side is 4 meters. This bottom part of the triangle matches the dimension here, which is 3 meters. And then the other side is also 4. So this is an isosceles triangle. And now I just need to know the height of the triangle. So the height of this triangle is the same as the height of the triangle in the front. So do you see how this arrow is pointing? So that means the height of that triangle will be 3.7 meters. Now I'm going to skip ahead and go to this front triangle because they are actually the same. They're congruent. So that's the same thing here. So that would be 3 meters is the bottom part of that triangle. And if I'm only finding the area at this point, I don't really need to know the slanty side. We're going to come back to that later. So the height of this triangle is 3.7 meters. Okay, so now let me get the dimensions of the rectangles in my plan. So this one right here has the top part of the rectangle, this top part, would be the same as this dimension here, because this one and this one and this one over here are all the same length. So that's 3.2 meters. And then the rectangle comes down here, goes across that way, and goes up here. So that means that this side here is 4 meters. So now I know that the rectangle is 3.2 by 4. This side that's facing us is actually going to be congruent to the other one because this being an isosceles triangle, because this is 4 and this is 3.2. So the blue rectangle and the red rectangle are the same. Not all triangular prisms will be like this. As a matter of fact, the next one we do, they'll all be different. And then finally we have this bottom part. So this bottom face here is this part is 3, and this right here is 3.2. So now I have dimensions for all 5 of the faces. All I need to do now is find the area of each one and then add them together. So to find the area of the rectangular faces, I just multiply the length times width, and then I wrote those numbers inside my plan. Now I'm going to find the area of the congruent triangles. Remember, to find the area of a triangle, you take half times the base times the height of the triangle. So when I did that, I got 5.5 meters, no, 5.55 meters squared. So now I just need to, now that's 2 of them, so there's 2 triangles like that. So I would just need to add all of those together. So when I add the area of the 5 faces all together, I get 46.3 meters squared. So the surface area is 46.3 meters squared. Now you might be saying to yourself, wow, that's a lot of work. is there a faster way? There actually is a shorter way, and I'm going to show you later if you like formulas, a faster way to do this. But for the next one, I'm going to show the plan again. But I will be showing you a faster way here soon. So let's make a plan again about this prism. And I'm going to identify that there's 5 faces. So one of the 5 faces is this right triangle here in the front. Then there is this rectangle here that kind of goes down. This hypotenuse goes across here. That's the actual part of the prism. And then down here. So that actually makes a rectangle that goes down like that. So this side here is 10 feet, and this side here is 5 feet. Then the blue rectangle I'm going to make, I'm kind of going around this shape. So now I'm going to go around the bottom here, what they're showing me. And it looks like a parallelogram, but really it's 5, and then this dotted side right here is 8. So I trace it, and then I label it in my plan. And then the back rectangle be 5, and then goes up, 5, and goes down, which is 6. So that's 5 and 6. And then finally, there's one more face, because there's 5 faces. And then that will be this back triangle. But the back triangle here is congruent to the first triangle. So that would be, again, 6, 8, and it's a right triangle, so that's the base and the height. So now I just need to find the area of each of these figures and then add them together. So here I wrote the workout for each of the different shapes, and now I'm going to use that to find the area of each shape and write it inside. So if you notice, each of the rectangles have a different area and have a different dimension. That's because this triangle is scalene. So when you have a scalene triangle, that's going to create 3 separate different rectangles going around the outside. Unlike the other one that was isosceles, and there was 2 that were the same. Now the triangles are the same, they're congruent. So the next thing I just need to do is go through and add all of the areas together. So 24 plus 50 plus 40 plus 30 plus 24 is 168 feet squared. Okay, so that again was how you can do this by making a plan. There's another way to find the surface area, if you're ready, that will make it a little bit shorter. If you would like to see that way, I can show you, or you can continue just to make a plan. So here is another way to find the surface area of this triangular prism. The formula that you would see in a formula sheet for any prism is, to find the surface area, is P times H, or possibly W, plus 2B. So P stands for perimeter. H stands for height, and that's height of the prism. And B is the area of the base. So this process is only going to work if you can correctly identify the base of a prism. Now, this might seem to you like the base of the prism is this rectangle that's 5 by 8, but a prism's base, a prism is always named by the name of its base. So since it's a triangular prism, its base is actually the triangle. So this triangle here, this purple triangle, is actually the base. So I'm going to need that. I'm going to need to find the perimeter of that and the area of that in order to be able to figure out the surface area, which we already have the answer to. We're going to do it differently. So let's start with redrawing that purple triangle. Oops, that's not a triangle. There. So that's 6 feet here and 8 feet here, and now we need the slanty side of 10. Remember, it's a right triangle. That should say 10. So keep in mind this triangular prism is laying on its side, and so it really should be turned upwards this way, where the base here is the triangle. That means that this side here is the 5. So the 5 feet is the actual height of the prism. So let's go back to our formula. We're going to need to know the perimeter of the base, and we're going to need to know the area of the base. Well, we already found the area of the base. We know that that was 24 because that's the area of the triangle from our earlier part of our problem. Now the perimeter is the distance around, so 6 plus 8 plus 10. So that means that it just so happens in this case the perimeter is also 24. That doesn't happen all the time. And this is 24 feet, whereas this is 24 square feet. So those are actually different things, even though they're the same number. So now that we have the perimeter and we have the area of the base, we just need the height of the prism. Well, the height of this prism is 5 because it's laying on its side. So it's the height is the distance between the bases. So these two triangles are 5 feet apart, so that's the height. So now I can use my formula. 24 was the perimeter, 5 was the height. I need to multiply 2 times the base because there are 2 of them. And that would be 24 is the area of the base. And so I just put that together and I get the answer is still 168 square feet. Now, if you're wondering why this works, why does the perimeter work? Well, the reason why is because, is if you could cut, let's see, let's imagine that we cut right here, down this line here, and then we cut off the rectangles that go around the triangle. Then this would be, it would make one big long triangle. So you'd have one long triangle that went around this, one long rectangle that went around this triangle. It would be this long. It would go 10, and then it would be 8 more, and then 6 more. So if we cut it off and we like unfolded it, it would be right here, and it would be 24. Then how the other side of that long rectangle would be 5. So by finding the perimeter, here's the perimeter, and you're multiplying it by the height, you're finding the area of what's called the lateral faces that go around the prism. And it's okay if you can use a formula and not really understand why a formula works. But this might be a little shorter for you if you are good at doing these types of things. So here in number 3 on your worksheet is a net. And a net is a 2-dimensional pattern for a 3-dimensional figure. So it's almost like so there already was a triangular prism, and it probably looked kind of like this, which is kind of tiny, I'm sure, for you, but that would mean this, if I'm looking at it from the side, this triangular part is the purple triangles here. And so this would be 3, and this would be 4. And then these lateral faces that have been unfolded for us to look like 3 separate rectangles, they go around that triangle. And so this would be, so this 5 would be here. And you can see, so this right here would be the 6, because there's 6, 6, 6, and 6. So all they've done is create almost like a map for us of this triangular prism. And what actually makes it easier to find the surface area, because we can see each of the 5 faces we need to find the area of. So I'm going to find the area of each of the faces and write that area inside. So this is a right triangle, so that's the height is 3 and the base is 4. I know that from here saying 4. So that means the area of this triangle is 6 centimeters squared. And if that's 6 centimeters squared, then this is also 6 centimeters squared. So the area of the yellow rectangle would be, well, this is 5, And this right here, this length is the same as this length over here. So 5 times 6 is 30 centimeters squared. And the length of the green one, the area of the green one would be 4 by 6, which is 24 centimeters squared. And then this little blue one here, blue, would be 3 times 6, which is 18 centimeters squared. And so I could just add all of those faces together to get the surface area. Now I'm going to talk about the shortcut I just talked about in the last section, but if you are not interested in that, you don't have to watch that part. So going back to the shortcut we just talked about, using the formula, remember how we said before that the P is the perimeter of the base. Now this is a triangular prism, so the base is going to be the triangle. So you just have to, doesn't matter which way it's laying, you just find the triangle. And this triangle is 3 by 4, and then I know the other side must be this 5. See how this 3 is here and 4 here, and then this other side of this rectangle is 5? That's going to come up and lay on top of here, of this triangle, and be 5 here. So I could find the perimeter would be 3 plus 4 plus 5. The height of the prism is the distance between the bases. So it's the distance between the two triangles. Well, these triangles are 6 centimeters apart. So I'm going to multiply that by 6. That's the height. And then I'm going to take the area of the base and multiply that by 2 because there's 2 bases. And we already found the area of the base to be 6. So that would be times 2, 6 times 2. And we talked before about why it is the way it is. So let's find the answer here, and then I'll talk to you about, see if this makes more sense about where the formula comes from. So the surface area is 84. So maybe this will make more sense now. So if you can see how this triangle is 3 by 4 and then by 5. So someone has cut here and then unfolded this triangular prism, fold it out so that this right here, this face on top, ends up here. And then here is this bottom part is this rectangle, and this back panel is this rectangle. So now you can see how when it unfolds, it makes one big rectangle that separates the two triangles. So this one big rectangle, the length of that rectangle is 3 plus 4 plus 5. 3 plus 4 plus 5. See? And the height of that rectangle is 6. 6. So that's where the formula comes from. See how we're adding these 3 plus 4 plus 5, that's the perimeter. And then that's the same as the 3 lengths added together. So that's where that formula comes from. So in our last example here, again, this is a triangular prism, and this triangular prism is laying on its side because its base is this triangle here, or the other triangle. So there is the base. So that triangle is a right triangle that is 9 by 12, and its hypotenuse is 15. So its height is 9, and its base is 12 centimeters, and it's right. And it's a scalene right, so that means we're going to have 3 rectangles that are of unique dimensions. So I'm going to make a plan for all those. So in my plan, in each of the rectangles I've drawn from the the triangular prism, I wrote the areas of each of those. So I have, base times height, base times height, base times height, and then the other one is 1/2 times the base times the height. So now I have all 5 faces, and I just need to add them all together. And then when I add that together, I get the surface area to be, I have 756 centimeters squared. So see if, hopefully that makes sense to you. I realize it might not be an issue of not understanding as much as it sometimes is an issue of it just takes a lot of work. But I don't know if you're noticing how I'm doing it, but I'm actually using colors, which I think helps. I'm tracing the shape and then I'm drawing it and labeling the dimensions. That's a major key because it's really difficult to figure out the different rectangles without tracing them and then writing down the dimensions. So now you have the other page and you're going to try some on your own. Make a plan. You want to, like I said, trace and then draw the plan, or you can use the formula, which is I explained previously if you wanted to watch the shortcut. But if you didn't and you are just making a plan and drawing it out and find the area of each thing, that's fine. Paying attention, number 2 says you want to wrap a paperweight shaped in triangular prism. How many square inches of wrapping paper? Square inches is the same as surface area. Number 3, you're finding the surface area, and number 4, you're finding the surface area. And this is the first time that these triangular prisms here in number 4 are actually standing straight up and down, with showing you that the base has always been the triangle and that the height is the distance between those triangles, which is going to be really key for when we're finding volume later. Well, thank you for watching, and hopefully this was helpful to you and made finding the surface area of triangular prisms less challenging, I should say. Thanks.